My name is Alex Boetzel. I'm head of residential innovations at Earth Advantage. We're a nonprofit based in Portland, Oregon, and my particular task is to look at technology as a climate solution and help implementation. And so, as part of that, we're actually a subject matter expert for the Building America program, which is a really exciting program if you are not familiar with it. And so we looked at heat pump water heaters. Before, like I've been with Earth Advantage for like about 2 years, and before that I was with a local design build firm called Green Hammer, and we've been building for net zero energy homes for a long time. And so we've been actually utilizing heat pump water heaters since the day of the air tap, for people who remember those. And as part of that, we have utilized recirculating systems and encountered challenges or opportunities, which then now in my new capacity, we were like, okay, we wanted to look into this a little bit more, and we want to make sure that the industry is educated around like the interactions between recirculating pumps, controls, and heat pump water heaters. Next slide. So obviously, really what we're trying to do is with recirculating pump is it's a convenient measure foremost, right? So we want to make sure that the weight for hot water is minimized as a convenience measure. However, obviously, and like the current weather is probably an indication, water conservation is huge. So if we are wanting to continue to drive down flow rates in fixtures, we need to even pay more attention on delivery times. And so we really wanted to understand like what are the opportunities to do that. And as part of this research project, actually, we also talked to Gary on the call and Larry. That was really helpful. We appreciate support and I acknowledge the expertise on this topic that we have on the call. So it'll be just a quick overview on our findings, and there's definitely more to understand. But again, like we wanted to make sure that like what are best practices and like what do builders, designers, and plumbing trade partners have to consider to really successfully deploy these systems. All right, next slide. When we did like a review of like studies that have been done, like, well, what are the savings actually look like? We understand water savings, it's energy savings. There's a wide variety actually on studies out there. Like this is the one in Palo Alto that really, as a result, show like dramatic, water savings and energy savings. To be honest, we had like a very small sample that we kind of like just in this process of trying to establish best practices, did like locally, did some research, and I think this might be a little overestimating the impact in general, but it just kind of shows a little bit of what the opportunities are. So besides the convenience factor, it really does, to a certain degree, has definitely quantifiable water savings and some energy savings measures, because we know there's less reheating of water if we're recirculating water. Next slide, please. However, just to say, we're using recirculating systems to make it more convenient for the occupant is falling short of what we have to consider when we are deploying these systems in conjunction with heat pump water heaters, right? And so this is a manufacturer recommendation here, or requirements, even with like a lot of manufacturers, and probably if someone on the call, you could elaborate on this, like are really understanding that there's concerns around particular uncontrolled or like not specifically controlled recirc systems, the impact that they can have on the performance of the heat pump water heater, and that the control strategies are really important to consider in order to make this combination successful. Get the most efficiency out of your hot water heater and get hot water delivered quickly and hot at the point of use. Next slide. So as a result, it's like most manufacturers, I think, this might not be true for all, but like I think a variety of manufacturers like, hey, if we need to, we can't control or we can't steer necessarily the control strategy. So like we're not recommending recirculating systems because it's just too important that the control strategy is correct to make it work, right? So that's the status quo. And so really what one of the outcomes of our projects will be actually a slide deck to educate the industry that will be available on the Building America Solution Center platform. So the hope is, that we can, collectively educate the industry on how to use this appropriately, again, to utilize the benefits, in terms of convenience and water savings out of these systems. Okay, next slide. So really what it is about is minimizing the runtime, right? So there's several control strategies, right? There's uncontrolled, but then there's systems like that are timer controlled, right? Which is probably what most people are familiar with. Again, we're talking about residential, mostly single-family residential systems here. And there's like a rush on hot water in the morning, right? So controls are often like running for a couple hours in the morning and then several hours in at the end of the day. So we're really talking about hours of runtime, which really, can have an impact on the performance of the heat pump water heaters because of the mixing, like in the hot water heater, or that, like a hot water heater, which is, like really is anticipating certain temperatures, like return temperatures, for example. If the return temperatures are too hot, it doesn't understand what it needs to do and will not operate it, as optimal as it could be. So timer, which has been, touted for a long time as like a savings measure, right? Because we're reducing it potentially from 24 hours to like, 8 hours in the day. However, that's still way too long for heat pump water heaters. So then we know that, there's smart controls. And really, I think it's important to understand that smart controls are still just a variation of a timer controlled. The only difference, and I'm oversimplifying here, but just for the illustration of the challenge here, the only difference is that instead of, like someone manually setting a schedule for a timer controlled, it will learn the behavior, but nonetheless, it tries to anticipate it when hot water demand is high and recirculate at those times, which still results in, I think, in run times that are too long for most heat pump water heaters. So we really kind of want to ideally minimize those run times even further. So next slide.
Hey, Alex, quick question on this slide. Do you is the top option you're saying just not doing a recirc pump with the heat pump water? Is that the first place to go? Is that what this slide is saying? And then do on demand if they really want one?
So this is really, and I apologize. This is where Bruce Manclark was supposed to be here in my set, and he put the slides together. I think really what this is in the retrofit scenario, right? So if you're replacing an existing water heater with a heat pump water heater, and there's an existing pump, right? So obviously, like the simple way could be to unplug the pump and talk to the homeowner about it to like ensure that it is like there's no controls, and so there's no impact on the heat pump water heater. But really, like I'm assuming if homeowners are used to the convenience of having a recirc pump, that we probably want to add controls, and it's great that there are systems, there are controls that can be added to existing pumps, right? Obviously, we want to evaluate the life of the pump and whether the pump is as efficient as it needs to be, but like we don't have to necessarily replace existing equipment as far as the pump, but we can add controls to it if we need to. Yeah, thanks for asking that question, clarification. All right, so on demand, obviously, like the title's like on demand is like the favored type of control, which means like, well, only if we really are needing hot water, let's actuate the recirc and ensure that we have pumps. So like now we're cutting run times, down to minutes in a day potentially, instead of hours before, right? Which optimizes, the performance of a heat pump water heater and also minimizes any kind of heat loss through the distribution system. And just to give you some indication here, there's a whole array of actuators and controls, that allow really any kind of level of control over this. And I think the most popular ones are either a push button, actuating button that can be placed either, in the vicinity of the fixture, right? So in a bathroom or in the kitchen, but it can also be, placed somewhere centrally, right? For example, I forgot who we talked about. That was a scenario I haven't considered before. It might have come from Gary or someone else. Like, if we anticipate that bathrooms are upstairs, maybe it's at the bottom of the stairs, right? And so as you go up, you hit the button, and by the time you get to the bathroom, hot water is essentially at the fixture. Now, that can be a little, complicated in terms of like, what about guests? What about occupants who are, don't necessarily understand these kind of controls, and children or others who like just don't understand how to actuate the system. So the other opportunity is a motion sensor, right? So that you enter a space like a bathroom, and the motion sensor picks you up and triggers the pump. It's important to know that also, as part of the optimization, it will not only trigger the pump regardless. It will first, there's typically an aquastat as part of the system, so it will only activate the pump if the return line isn't hot already, right? So that means, you could argue like, hey, what if I walk in and out of the bathroom like 10 times? Does the pump run 10 times? It will only do so the first time, right? And then it will basically, there's some checks and balances that like, hey, the recirc pump, the system is charged, so we don't need to trigger the pump again. So those are generally the two options that I think most convenient. There is retrofit options, or like if for some reason a wireless option is desirable, then there are options like that too. Like on the left, there's some Bluetooth based actuators which will allow like to install these systems, the control systems, even after the fact, in case like wiring isn't an option. And which is, by the way, one of our findings, like, and again from my practice, is really in the single family home construction can be a challenge, because now we need control wires for these, which you would probably assume would be in the scope of the plumber. However, in most residential plumbers, if they're specializing on single family only, are not used to using control wires. So like we had a couple times where that was out of scope for everyone. The electrician might not remember or ask about it. So if there isn't the understanding that we need control wires, then that can be missed, right? But then we have other options, wireless options, that can help us with that. Finally, other systems we've seen is like draw activated. That's another retrofit measure. So once I start drawing at a tap, right, or recirculation has a significantly higher, like larger diameter. So if the pump kicks in, even though we're drawing water already, it will kind of accelerate the delivery of hot water. My experiences from limited experiences, that it cuts the wait time maybe in half, depending on what it would have been before that. So if you have an actuator like a push button or a motion sensor, you can literally reduce that to seconds, right? Which is really like, it's almost instantaneous hot water with these systems. So I think that is my last slide. Do we have another one? Yeah. So really, just a quick summary. Like, controls are important. Like we're saving energy and water, and we need to make sure we have the proper controls to ensure that the heat pump water heater operates optimally.
Thanks so much, Alex. Appreciate that. Yeah, and thank you so much for filling in for Bruce on short notice as well. I do know that I saw Gary Klein and Larry Aker on the call, and you all are super experts as well, as Alex mentioned. Just wanted to give you a chance to say anything before we take a couple questions. Let's put you both on. Yeah.
So the time to tap depends on the volume of water that's in the pipe between the loop and the fixture. In retrofit, we rarely know what that volume is. So it's hard to predict time to tap because we really don't know the layout of the plumbing. If Jay knows the plumbing in the houses he's been building, he can estimate the pipe length and therefore the volume. And it could specify it in new construction to be no more than X, which would cap the time to tap question once the line is primed. And so the idea of all of this strategy is to prime the main line with hot water shortly in advance of the desire for hot water, and then tell the pump to turn off. That's the whole strategy behind the controlling. Everything else is a guess. I usually ask it as a question, does anybody know when they plan to take their next shower? I do. It's either tonight or tomorrow morning, usually. I'm a morning shower guy, okay? I know it's going to be tomorrow morning. I do not know which minute it's going to be because I haven't hit the snooze button twice yet. And so once I'm ready to head to the shower, I tell the pump to turn on. That's the simplicity of the strategy, but it needs to anticipate the time. By how much? Depends on how fast the pump can move water through the pipe. That's the physics, right? One other thing to remember, it takes twice as much volume of water that's in a pipe before hot water hot enough to shower in comes out the other end of it. So if you've got a cup in the pipe, it takes 2 cups for the hot water to arrive. If you've got a quart, it takes a half a gallon, etc. All right, enough on that. But the idea of the control strategies is absolutely essential. I didn't hear, is there going to be any physics research done to actually compare control strategies? Because I really think we need to do it for simple pumps.
I was going to ask that as well. Yeah. Any field studies?
Yeah, nothing. I mean,
I want a field study. I want a controlled study of controls in a lab so we can actually compare the controls to the controls. Once you're in the field, I got to run the same test on the same house with different controls. No one's going to let us do that.
Yeah, I think unfortunately, beyond the fact that we're uncovered that that's necessary, again, confirmed that that's necessary, these kind of studies, we haven't gotten to the point yet to get to a project that would do that. So nothing's planned on our end besides like that we determined that that's kind of necessary to really understand these control strategies better. But yeah, nothing in the works yet. But hopefully we underline the demand.
Reach out. We'll talk about it. I know there's some interest.
Great.
So let's figure out how to get it started.
That sounds great. I'd love to collaborate on it. And maybe just to add real quick to like what Gary was saying. Obviously, like I was trying to limit the presentation on pump control specifically, but obviously the distribution system and pipe diameters and lengths from the loop to the fixture and pipe diameter, they have a huge impact, right, on the performance of the system. So thanks for pointing that out, Gary.
Yeah, thank you. Okay, I think Barry and Chris, we're going to have to do quick rapid fire questions. And then Jim, I saw your question in the chat and we'll see if Alex can answer that afterwards. But so Barry, go ahead.
No question, just a statement. I think the industry needs to get together on this because heat pump water heaters are getting a bad name and recirculation systems are getting a bad name because in a typical application, there's a gas water heater in there. I'm work for Grundfos, so there's a Grundfos hot water recirculation system. The homeowner buys a heat pump water heater. The contractor goes there and unplugs the recirc, and the homeowner says, I just spent $5,000 and I got to wait 3 minutes to get hot water. So I put back my old gas water heater. It's not the heat pump water heater. It's not the recirc system. The industry needs to get together and send the message that it's a new control strategy that will solve your system. Not the heat pump water heater is bad. Not the recirc system is bad.
Right, and similar to add to that, right? Same as with low flow fixtures, right? We hear people complaining about low flow fixtures, and it's not the fixture; it's a distribution system, and it's exactly why we feel like we need to educate. And at Earth Advantage, we do a lot of educations. We're going to use the material for online webinars and on demand to do exactly that. So I totally agree with you. Thanks for pointing that out.
Thanks. Yeah, great point. Thanks so much. And Chris, do you want to ask your question real quick?
Oh, I just wanted to make sure I'm clear about one thing here, and I know that Bruce put this presentation together, and he's not here, but any recirculating system. Well, is this the case? Is it that any recirculating system is going to have a energy penalty? What it does is saves water and uses energy, and the question is, how do you minimize that additional energy consumption? I mean, certainly what we've seen in California is that recirculating systems without controls waste a huge amount of energy, double the energy consumption for water heating. So it's really that's the trade-off that we're looking at, and of course the convenience issue.
Right. So I let others chime in. Like what we found, like we were just did the simple math and like, oh, what is a pump? How often is it actuated? How much does it actually run? And if you really combine it, over the year, it'll be less than a kilowatt hour a year that it will consume the pump itself, right? So the energy penalty of the pump is almost negligible. Those are pennies. The energy penalty based on heat loss through the recirculating system. We obviously want to insulate the distribution system to minimize that. And again, by precise controls, we minimize that heat loss dramatically as well. So this is, again, I think where the research comes in that Gary was mentioning is there's a little, the savings that we're seeing is also by recirculating rather than drawing hot water, right? If we wait for hot water, we will have cold water replenish the tank as opposed to recirculating room temperature or even like slightly warmer water to the tank. So there's going to be some reheating savings on that. But again, like I'm happy to defer to others to add to this.
Yeah, Larry, how about 30 seconds, Larry? Because we've got my colleague Noah is waiting in the wings. Could you answer that or chime in for 30 seconds? I see your hand up.
Yeah, well, first of all, thanks, Alex, for giving the presentation. I know Bruce was going to be there, but I think the conclusion is basically you do not want to run anything on a pump that's not under some type of control. And after 30 years of experience and testing since 1994, we've learned that there's a great way to do that, and you can do that very efficiently and very effectively on not only existing homes that have standard plumbing, meaning they have a water heater and they have standard fixtures with no circulation. There's a way of circulating that water effectively and efficiently in those homes. And Bruce could answer that because he's got that kind of system in his own home. On recirculating line systems that are running full time, you definitely don't want to be running them full time. So we have controls to operate that to cut that resistance down. And we'll be adding about 20% energy efficiency to any heat pump water heater simply by not allowing that water to be heated that's not being used.
Thanks, Larry. Appreciate that.
Yeah, and so
go ahead.
Just final words. I want to say, like we talked about, that more research is necessary to understand this better. But I think the takeaway really should be that these systems are well matured. They work well. Like we use them in a lot of projects. It's really the control strategy that matters. There's a little bit of a learning curve, but once that's understood, I think these systems are excellent and really deliver on what they're promising.
Okay. No, I think we're going to give you an extra 5 minutes at the end, so if folks can stay with us 65 minutes today, that would be great. Because I see one of our VIPs, Steve Broaden. Do you want to get final word in on this, Steve? Great to have you on the call. Final word on recirc pumps.
Oh, thank you, Joe. Can you guys hear me? I'm actually in the field right now.
Yeah.
Good. So no, this is definitely an egg we've been trying to crack. Anybody on this call that wants to work with us, Joe can get you our information. Pretty much all of our business is heat pump water heaters in the Northwest, Oregon and Washington. And this is an issue we've been running into for years. I feel like we've been getting closer to an answer. Retrofits is what we do, not new construction. So retrofits are definitely the most challenging piece. And we found a company out of California that does a pretty cool thing. They have an actuator pump system they designed basically out of a garage. I used them 3 times now. And successfully. How does this work? Just real quick. This thing basically has an actuator that goes on the hot side. So as soon as the water flows, just like a tankless water heater, it engages the pump. So it alleviates sensors, buttons, which bathroom do I put the bypass valve in? I'm kind of happy with this product. So if anybody wants to get some information, I'll try to pass that company on to you guys. But also we believe in smart plugs. Smart plugs have been working well for us. I think the big takeaway though is we all come to these meetings as kind of the smartest people, and we have to never forget that at the end of the day, a little bit of loss in savings isn't going to matter to the consumer as long as they have their hot water. We got to look at all the waste. If we're using a little more electricity to use a pump, then how much hot water are we saving is a precious resource, and that part of the bill that the consumers have to deal with. So I think there's a lot of work to be done here. I think they're getting close on product. I'll leave it at that.
Thanks so much, Steve. Appreciate it. With Great Northwest, one of the leading installers of heat pump water heaters nationally. Thanks. Appreciate it, Steve. We'll have to close the conversation there. Thanks so much, Alex, for that great presentation, and everyone for chiming in. It's a really important subject for all of us water heating geeks.